Okay, so before moving to the sliding meshes case, just to a reminder, data structure in all these cases. So it's on sol logs, you have all the solution files, so self-explanatory, you go there and you can plot the forces, do the visualization like within the previous case, and so on. There is no problem. Then also here, well, these two, fine mesh, quartz mesh, there is no boundary layers. You want to compare quartz boundary layer, you have it there, see the influence and so on. As I say, I run the cases with no boundary layer just to go fast now while doing this video, but it's up to you. Then solutions, you have the solution file. So fine mesh, just go and copy constants and the solution, and then you can post-process. Okay, so remember, basically just you need to take one case. Let me take this one, no NCC, put it here, copy from there, put it there, and you are ready to go. Okay, so without the need of regenerating everything with no boundary layer. Okay, so let me put here override, and now let me visualize. So that is the case structure. For all cases, you have this something similar, so don't forget that. But let me visualize here, and to show you something, let me open paraview, and I want to show you something, because this probably will be the last keyword that I want to show you in the snappyHexMesh dictionary. For this case, it is very important. So don't take for granted this geometry. Now there is a lot going on here, and what I want to show you, let me zoom in, let me go here, let me change color. So now this is a quartz mesh, as you see. Well, it's not perfect. Okay, could be basically be so that you can see that something finer will be much better. But what is interesting, what happening here? Okay. So look at that, you have the region that is moving or potentially moving, and then you have all the fix now. So here's where you are adding that source. But look at that, we have a very nice matching. Even though you have these differences there and those errors that you see when doing the NCC, that mismatch, it's just basically this. Okay, you get the idea. You have that region here, now that edge there, you can add refinement as we have in the finer mesh, and later we'll open that. So there is not a big issue, okay? But we have been doing everything, and I haven't said we have been doing everything now. And I haven't mentioned this specific keyword that is very important for that. And here, let me just open this, take this file, and to show now the finer mesh. Okay, paraview, paraphone. Let me just build in. Oh, now building is not going to work. Or probably, I don't recall if I have the NCC there. Probably, yeah, no, I don't have it. Okay, so this is a large mesh, so it will take some time to open. Yeah, this OpenFOAM format it tends to be slow, so to mention, I think inside my personal experience, inside format is the best one. Then you have the BTK also, that it's much better than the native of paraphone. Okay, so we have this, and okay, so this is the fine mesh and body. Zoom in, put it there, and look at that. By getting a finer mesh, many issues are solved, stuff here that you will have in, and so on. So if I zoom in here, look at that. Even here, you fix many issues. You still have some small problems there, but not a big deal. Then you can also capture this edge here and make it finer. I think we already addressed that, and we saw that. Okay, but this is it. So what I want to show you now, font clean tutorials, the final keyword, and let me go to the course. snappyHexMesh, this is the one that we're using, this keyword. Extremely important, and actually I don't see any reason for put it false. Okay, so if you go and look at the tutorials that comes with OpenFOAM, which by the way, those tutorials don't represent standard practices. You would see that it's always false. I've done my own benchmarking. I see no reason to put it false. Leave it to true. But let me show you in this particular case, because you are going to see this effect just in this particular case. You have a comment there, and let's redo this geometry and you will see what is the effect. Okay, so put it there. There is no need to change anything. So this is related to the snapping when you have multiple STLs, like in this case, remember you have the body and the propeller. They can be separated or they can be inside the STL, doesn't matter, but you have these multiple objects. And let's take a look, what is the influence of this one? Is very important. And my advice, it is leave it always to true. I don't see any reason to put it false. And then also regarding to the snapping, I also recommend you always explicit snapping. That is the one that you use feature extract now to get those features. So at this point we have the mesh. And okay, it's doing checking quality, saving files. In particular, this one also will give you a lot of problems with boundary layer. There is something that you don't see until you really need it and you realize, this is the issue. So now let me go there, paraview. So remember, we're looking at the coarse mesh, but if you do it with the finer mesh, you are going to get the same error, probably lower because it's much finer, but you are going to get the same issue. So basically, prop body, go there, zoom in, change color, and I think you already see the error. There you go. This interface here. This is the error that you get when you don't use that option now. And if you have multiple now bodies STL, like in this case, you have the STL or the object now for the body and then for the propeller. And this is the issue. So by simply enabling this, and let me go through, you are fixing that problem. And here, in this case, if you go and you say, okay, now let me put a super fine mesh here with this option false, you are going to get this error. You are not going to solve it. Probably you are going to mitigate it a little bit, but you are going to get it, and this is really bad. You can get the idea, the interpolation, NCC, all this, that stuff is not going to work in NCC. And if you have boundary layer, it's going to give you always problems here, very bad quality cells here, okay? So this is what is happening there. So now let me put it to true, so just to show you real time that actually is doing something. And let's redo the mesh and let's wait for the final result. Okay, so we're back. We have the mesh. Let's launch paraview and let's see here the effect of that option. So let me go here, body and prop. So as you see, seeing that the structure, nothing has changed in the patches, naming. And if I zoom in here, clearly you see that the problem has been solved, okay? And there you go. So visually there you can see what is the influence of this option, okay? MultiRegionFeatureSnap, okay? I think it's self-explanatory. As I mentioned, no reason why to put it false yet, and it's something that it is only used, or it has an effect when you have now multi regions, okay? So in all the previous tutorials that probably you open, I think you are going to see that it is false, but it's false because I didn't have multi-region. But if you have multi-regions, put it through, because it can help you a lot in these situations. Okay, so this is a classical situation, and in the previous case where it's both false, the simulation will run. Okay, but you see that you're going to have some instability problems, some issues, or maybe when you go to NCC sliding, maybe no, if I will recall, it will diverge. On what point it will diverge. Also, adding the boundary layer is super tricky, or probably doesn't work, I don't recall, but it's up to you to play around and see, you know, the effect, and just draw your own conclusion. But as you see, even as you start to refine this region, you are not going to improve that. You are going to always get that error. So I think that is the last parameter that I wanted to comment here in Snap. For the rest, I think nothing to comment. Just take as my guidelines, and I think you are safe. So that's all for the MRF. Now, next videos, we move to the sliding meshes. The approach is pretty much the same. The only thing that is going to change now that it is full and steady, and we're going to see, you know, to test the mesh motion. That's all. So thank you, and see you next time. Bye.